Welcome, everybody, and thank you for joining this webinar today, which is hosted by the Collective for the Advancement of Connected Buildings in partnership with PropTech Collective. Our focus today is on accelerating Canada's transition to net zero with specific emphasis on electrification of commercial buildings. Now, we are very pleased to have Peter Love to moderate today's panel. Peter has been an environmental activist for over 5 decades. Without further ado, Peter, the floor is yours.
Thank you very much, Yuri. We've got some really good panelists. So I just want to go through with you what we're going to do here. There's 3 aspects we're going to focus on. Sarah Simons is going to start us off with the discussion about the business case and why electrification is so important. She's with Power Authority. She's a director of utilities and innovation and been in this area for a number of years. Then we're going to look at the electricity system itself, Toronto, with a focus on Toronto. And we're delighted to have with us Michael Patrick from Toronto Hydro. And he's going to talk about the electricity system in Toronto, its capacity, and to gear up and to provide the power that would be needed for this transformation for downtown buildings. So those are the sort of 2 introductory comments. Then we're going to have 3 case studies, and I think that's what we really want to focus on. 3 companies that are going to be here giving us their insights on their experience. We got Lee Hodgson from Dream. I'm sure you're all familiar with Dream as a leading company. He's the head of sustainability and technology services. And then we have Paul Barton from BGIS, who's going to also the director of energy and sustainability, going to talk about their work, which I'm sure some of you will know something about. And then we end up, last but not least, certainly looking with a presentation from Joe Brown from Kingset, who's going to be talking about some of their recent projects. Let's move on to Sarah, and please give us some background about why we should be caring about electrification. And this is a great week to talk about it, I think.
Sure is.
It's quite good.
Yeah, thank you so much. I'm delighted to be here today. So my name is Sarah Simmons, and I'm Director of Utilities and Innovation at Power Advisory, which is an energy sector management consulting firm, and we focus in the North American markets with a lot of operations all across Canada. I'm based in Toronto, Ontario. So I wanted to first just set a little bit of broader context. So Canada has committed to reducing GHG emissions to achieve a net zero target by 2050. And we also recognize the pivotal role that the building sector plays as it contributes to approximately 18% of the national emissions, GHG emissions. Approximately 77% of that is coming from combusting fossil fuels for space and water heating. So as we're facing these challenges, this is, looking at the building stock in Canada, there's just about a half million commercial buildings that are going to require concerted effort if we're going to even approach any of these targets. So, taking a step back, looking at businesses, generally speaking, businesses are looking very practically at reducing their overall costs. But more often, those businesses are also looking at achieving sustainability objectives that are aligned or even potentially more aggressive than the federal targets. So those buildings, looking, for example, at reducing emissions, or even some businesses looking at fueling their operations with 100% renewable energy to meet ESG targets. So electrification is really about future-proofing its operations and demonstrating as well commitment to corporate responsibility. And electrification, again, aligns with the shift in a more sustainable pathway to reduce carbon footprint. Most Canadian buildings can immediately reduce emissions by transitioning to electric heat. In regions of Ontario where there's clean electricity grids like BC, Quebec, and Manitoba. Those emissions reductions are quite drastic. And even in grids where there is more emissions intensity, it's really considered a strategic investment, as we understand there's a broader transition happening leading to decarbonization of those grids. For example, with the proposed federal clean energy regulation, but also a number of those provinces are already on a path to decarbonization. So there's strong rationale to choosing electric heating, such as heat pumps, and it's very compelling these days, given energy efficiency and the versatility of these systems, as well as the potential for long-term cost savings. But that said, we know that some of those decisions are tough, right? So we know that there's still cheap natural gas that could potentially pose a hurdle when you're thinking about the business case. And even things like electricity rate structures that incorporate things like peak demand charges. Those are factors that businesses will need to be considering. But overall, with the rise in carbon pricing, with the rise in cost of natural gas, reducing costs potentially for some of the upfront cost, these types of systems are becoming more attractive to businesses and more feasible from an economic standpoint. So in general, just leaving, with sort of like top three objectives or top three options for deep decarbonization of buildings. Number one is obviously focusing on the space heating, air source heat pumps, ground source heat pumps, or a combination, depending on what the facility's requirements are. We need to think about the building envelope, so embracing energy efficiency retrofits and also energy efficient designs. And then incorporating renewables into the facility as well. So with that, obviously my fellow panelists are going to delve into more detail, but I really look forward to the discussion.
Thank you very much. That's perfect. Right on time and very succinct, and thank you very much. All right. So Mike, give us a bit of perspective from Toronto Hydro and where our system is at and the ability to meet this challenge.
Thank you, Peter. Yeah, so I got a little bit of context for the climate action team as well. So back in 2021, the city asked Toronto Hydro to plan out the support for Toronto Hydro or City of Toronto's net zero goal by 2040 by delivering GHG reductions, stimulating local clean tech, and leaving nobody behind. And Toronto Hydro is doing this by expanding the electricity distribution with the grid expansion and modernization, creating the climate action team, which is what I'm part of. I'm part of the large buildings, 50 kilowatts and above, and as well as providing guidance and making connections to other organizations and funding opportunities. With respect to the grid modernization and expansion, which is going to be required to meet the net zero challenge, this will involve us roughly doubling the size of the grid by 2040 by building smarter, more efficient, and reliable grid and using technology to get more out of our existing equipment. Now, one other important factor is right now we are a peak summer utility versus with electrification, we'll be probably moving towards a peak winter. Just for a simple example on that, if right now your chiller consumed a peak demand in the summer of 1 megawatt, and you calculate that your peak winter demand with installing heat pump is also going to be 1 megawatt, then you're not actually causing an expansion to the grid. Please still talk to us, but there isn't a grid expansion. And similarly, if you were to calculate, oh, I need 1.3 megawatts of capacity, it's really the delta. So it's 0.3 megawatts of extra expansion that's required. And another point to factor as well, when referring to the electricity system, there is a difference between generation versus distribution capacity. And Toronto Hydro is obviously a distribution company, so we're in charge of the transformers, poles and wires, getting the electrons from point A to point B. And I think, as we're probably going to hear a bit today, there's multitude of scenarios that the demand and Toronto's long-term electrification needs will depend on the pace of electrification. And because of that uncertainty in our 2025-2029 rate filing, which was just submitted recently, we're proposing a least regrets investment that positions us well to address electrification needs as they develop. And to put a little bit more perspective, from 2022 to 2029, we're looking at approximately a 40% increase in our annual investment in grid and operational capacities that will allow us to continue to deliver safe and reliable services to our customers and enable climate action. Toronto Hydro actively updates our load forecasts with its annual planning, cycling, and modeling to figure out where growth is going to occur. So my one ask is, the minute you start to think about your plan for decarbonization, even if it's still 10 years away, because technically 2040 is 16 years away, talk to us now. Come talk to my team, because we can start then putting that into the planning system and cycle and talking internally. And, just a friendly note, building capacity is what Toronto Hydro does. We've been doing it for over 100 years, and we do hundreds of connections a year. So we are very competent in doing this. So the conclusion I want to leave is, like Sarah said, Toronto Hydro is ready for electrification, decarbonization. We're here to support you, and please come and talk to us as soon as possible so we can start working on your path to decarbonization. Thank you.
Excellent. Thank you very much. Great perspective, and good to hear that your long-term planning is alive and well, and we seem in good hands. So as I said, the focus of today really is going to be on 3 case studies, and we've got 3 great speakers. So first, we're going to have Lee Hodgkinson from Dream, and who's going to talk about some of the work that they're doing. And Lee, I'll hand it over to you.
Thanks, Peter. Hi, everyone. Very nice to be with you today. Today, I'm going to talk about one interesting electrification project that Dream currently has underway, 67 Richmond Street West. And Rachel, if you want to, you can pull up the slides in the background while I'm talking. But 67 Richmond Street West is a 50,000 square foot office building in downtown Toronto. And it is included within our net zero by 2035 boundary. This is what we call Dream Office REIT's latest sustainable redevelopment project, as it's an existing building. And basically, we're repurposing this 80-year-old heritage building into a net zero ready, luxury boutique office building. At the start of this redevelopment, we engaged a sustainability engineering firm to conduct an in-depth greenhouse gas emissions audit. We created a calibrated energy model using eQuest, and we produced a ASHRAE level 2 energy audit in alignment with our net zero action plan, which I encourage everyone on our website to check out. This engineering firm worked also closely with our mechanical and electrical consultants to optimize a retrofit plan that created operational improvements while also controlling for costs, especially operating costs and capital costs, as well as construction risk. Thinking about what the building started at, the pre-retrofit HVAC system included perimeter electric radiators, and then as well as whole floor single zone compartment air handling units, or AHUs, with packaged direct exchange cooling and fresh air intake dampers, again at the floor level. And we used district steam to heat a hot water loop that fed the compartment units for makeup heating, as well as other types of heating for the floor. So at this building, we evaluated many different HVAC retrofit options, such as like-for-like solutions, where we kept the electric rads and existing ductwork and just installed new floor-level air handling units. We also evaluated central heat pump rooftop unit options. But the recommendation of this technical analysis and discussion was to proceed with a full modernization of the mechanical electrical systems, including the selection of variable refrigerant flow, or VRF, heat pumps as the primary heating and cooling system. As we saw it, there are many advantages to VRF. It is basically the most energy efficient, GHG efficient option that we looked at. It has exceptional part load performance across interior and perimeter zones, and that often have in office spaces simultaneous heating and cooling loads. It also provides precise temperature control in each thermal zone to improve tenant comfort. As you can imagine, the existing electric rads were not great for precise temperature control unless we added an expensive controls package on top of that. This solution also gave us the ability to increase the number of thermal zones on a floor and in the building, not to mention let the tenants customize their zone configurations, i.e. move boardrooms around, offices around in a pretty easy manner. In addition, at 67 Richmond, we are installing an energy recovery ventilator, or ERV, to provide ventilation and to precondition the fresh air as it is cycled into the building. And we actually also managed to complete some building envelope improvements, which improved the insulation and air tightness. And this led to a 10% drop in the HVAC sizing, which of course saves us upfront equipment costs. The combination of VRF and ERV technologies, in addition to some of the other energy efficiency upgrades, are estimated to save us 61 tons, which is 55% of the GHG emissions at this building. And we estimate this will achieve over 30% energy reduction, which of course contributes to energy cost savings for tenants. I'll also note that this project was certified as one of the first investor-ready energy efficiency, or IRE, projects in Canada by the Canada Green Building Council, and is included in Canada Infrastructure Bank's funding initiative with us. I'll note that we also did leave the steam system in place as a backup because we felt that that gave us more optionality for the future and redundancy. And so just to reiterate some of the lessons learned that I want to share with everyone, engaging heat pump manufacturers, energy consultants, and mechanical electrical consultants early on in a collaborative manner was very important. There are a lot of products out there, many of which are not tested for our climate. Also, there's a lot of products out there that don't have real world testing performance data. And we need that data in order to inform our energy models accurately, as well as our HVAC design. I'll also flag that trying to improve the building envelope up front led to this HVAC equipment cost savings and lower future operating costs. So that was a big win in our mind. And then as we are developing this building on spec, as in we do not have a tenant in place while we're doing this redevelopment, it's really important to maintain some design flexibility and options for future tenants to reconfigure without wasting money. I've definitely seen in the past, landlords build out this really great HVAC system, and then tenants basically tear it down and rebuild their own. That's not an ideal situation, and it's definitely not cost effective. Finally, I'll conclude by just reminding everyone that our philosophy is that every time you have the opportunity to touch a system, you're spending money on it and replacing it or upgrading it, that is the best time to align it with a net zero roadmap, which is really important for us if we're going to hit our 2035 targets.
Great. Well, thank you, Lee. And what I might do, I see we've got 2 questions for Lee in the chat already. I don't think we'll take them just now. I'll ask Lee to have a look at the questions, and so you can be ready to respond to them. Let's move on to our next speaker, and that's Paul Barton, who is joining us from BGIS, and going to talk about some of the work that they're doing. And so, Paul, over to you.
Thanks, Peter. Hopefully you can hear me. So I think the best thing to initially give some context is I work on the Government of Canada account with BGIS. So over the last number of years, we've performed carbon neutral studies on over 100 buildings across the country. And so what that really led us into is, as can be imagined, a big focus on electrification. Another bit of the context behind that is also that the government is looking at procuring a lot of renewable energy to work to reduce their electrical emissions as well. So that even further, even in emissions, or provinces with higher emission factors on our electrical grid, are still driven us down a very similar route across the country. And what that really taught us was there's kind of 2 ways of handling it. We've had opportunities with regards to full building renovations, where we might be able to do lots of things with the envelope, and I'll get into that in a moment with a project. And then we have the other option where we have more trying to work within the current structure of the electrical system in the building. So where can we make adjustments, operational changes? Do we have access to both electrification of the heating system and the existing backup, whether that be fuel oil, whatever that might be? So we very much sort of learned that the envelope aspect of it is a real big deciding point for us. As I say, we'll get into St. Clair, which is one of our sort of flagship buildings in a second, but the element of, hey, if we can or can't do the envelope really being a deciding point around that midlife refit aspect to how we deal with things. So the example building that I've got to talk to today is 25 St. Clair, and that's a building in Toronto we've been working on. It came up for midlife refit, so we were able to look at the whole building and look at all of the government's objectives, whether that's Indigenous engagement, wellness, active transportation, all those kind of things as the building was being renovated. And this building has mainly gone with the geothermal system as or geo-exchange, I should say, sorry, system in the basement. And that was actually retrofit into the building's parking garage. It was a very complicated drill session where we had over 150 meter, basically ball holes, that's the word I'm looking for, ball holes taken through the ground, all at sort of slightly different angles to spread out and to be able to deal with the height restrictions in the parking garage. The building also had a full building envelope upgrade, so that allowed us to deal with the air tightness, energy efficiency issues, so we could try and make sure that the heating requirements of the building were within a reasonable a load. And because we were doing a renovation of the building, we were also able to look at the full building's electrical systems as well at the same time. So we did do additional things on there, like adding PV panels. They cover about 15% of the electrical load for the building. There's over 800 of them on the roof. It covers a huge array on the roof. But even then, we still were looking at to try and generate enough heat and all the electrical needs in the building. It was still going to be a big demand. So that has been an area where using the envelope aspect was able to allow us to make a manageable sized geothermal system, where we had the space just under the building, and that was it. It's very much an urban lot, and that's how we kind of proceed with that. And that building is just about, I believe, handed over to the client now. And I can tell you, last year we had the winter heating. We didn't use any natural gas anymore because it was a flagship building. It's the first time we were doing this. We had the geo-exchange system, we had a backup electrical boiler, and we had an emergency gas boiler just in case, because everybody needed to feel confident. That gas has never run since we started those heating systems up, and we have had a number of construction challenges throughout, but we've managed to get through and keep the gas turned off. So we hope to use that as an example going forward for many other retrofits like this. I think the only other thing I would mention beyond the aspect of other buildings where we're having to work a bit more within the scope of the existing electrical system, transformers, whatever, we have had on those smaller scale buildings a little bit more interest around how do we select the optimum equipment, whether that be, hey, should we go electrical humidification? Should we go to a backup boiler? Decisions around how much are those each going to be used? How can we maximize or minimize the amount of emissions and savings? And I think trying to keep flexible as we go forward and not assume that there is a one size fits all, hey, we have to renovate everything. We can still do things with what we have and optimize that with controls and strategies to offset maybe peak demand charges, offset larger amounts of emissions. We have oil burners or oil boilers that are going to be being replaced, and we're looking at switching out one of those electrically so that we can kind of do a combination and allow flexibility in that. So it really allows a reduction in emissions without completely having to lose all other opportunities. And then maybe finally, if it's of any interest for others, we do have an experimental project we're doing now in the Atlantic region right now, which is we're actually working with the LDC there, the local distribution company, to figure out how we can store electricity in a battery that's on our site, and then share control of that with our local distribution company to help them with peak demand shavings as well, beyond just our building. It's an electrically heated building. We installed a big PV system, and the battery was included as part of that project. Control is mainly in the hands of our BAS system, where we can adjust our peak demand savings, but at the same time, we're also sharing that equipment with the local distribution company there to allow them to figure out how they can adjust that. And I think there'll be probably more of those type of initiatives coming in the future, but if anybody has any questions on that, we can maybe go through that a little later on, depending on time.
Great.
So I think I'll hand it back
Thank
to you, Peter.
Paul, and once again, you've got some questions in the chat, so
I'll
have
take
a
a
look at them. And I see Lee's already been responding to some, so that's great. So the extent to which you can respond in the chat, that's great. But we'll also have a chance for live Q&A at the end as well. So thank you very much, and let's keep that going. All right, our third speaker is Joe Brown. He's with Kingset. He's the VP of Decarbonization and Building Technology. And I think we're all in Toronto familiar with some of their properties. And Joe, give us some highlights.
Sure. Yeah, I want to talk about a couple of projects we've completed here, and they're both in Toronto. The first one is Scotia Plaza. So we've got Scotia Plaza was one of the first. There's some argument on whether it was the first. It was definitely the biggest zero carbon CAGBC zero carbon certified office building in Canada under the performance path. It is a building that has been electric from the day it was built. Over the years, it has gotten a lot of upgrades. Heat recovery chillers to be the biggest one, which allowed us to become substantially more efficient. It does have electric boiler backup. In the time that I've had here, Lee's actually had a little bit of a role in this building back when Dream owned this place. But we kept the electric boilers in place. We rebuilt them, so now it will be electric for the remainder of its life. We felt it was very important to get this building certified just to show, look, a 1.4 million square foot building in downtown Toronto can run on electricity, emit very little, and be competitive in the market. Scotia Plaza has been doing it since it was built, and it's competed with all the other major towers in the core. So that was the first one that we got certified, and then we moved on. There's a couple of others. We can talk about the Royal York is one that was certified a few weeks ago. You may be familiar with it, across from Union Station in Toronto, 1929 construction. It needed a lot of work behind the scenes. It was steam run building, N-wave steam and for heat, and it had 3 800-ton chillers in the east wing, which was a 1954 expansion. We knew we had to do mechanical work there. All of these projects that we've done have really been driven by end-of-life mechanical equipment. If you have a chiller at end of life and you look at what you could do like for like or business as usual approach, and then apply I would like to do to decarbonize, and you kind of come up with a long-term plan, the numbers start to make a lot more sense than if you, like, for example, this was a $65 million project. About 55 of that had to be done anyway. It was old pipes. It was things that were definitely at end of life. If I was to just renew my N-wave steam contract, I needed to do a lot of that work. So the additional 10 million to go zero carbon was a very small uptick. In this case, we connected to Deep Lake water cooling, which is available through N-wave in Toronto. The connections were actually stubbed into the building some time ago. They were there when we bought it in 2017. I don't know the exact date, but when they ran the pipes down Front Street, they brought them into the building. So we connected to Deep Lake. That did a number of things. It reduced some of our peak capacity because we're no longer running chillers on site. We're using Deep Lake chilled water. And that the other side of that is it allowed us to heat the building with heat pumps. So we actually run the Deep Lake kind of in reverse. We pull out of the return side of the water, and this essentially gives us, I compare it to a ground source system. And so instead of pulling out a ground source, you'd be pulling out of the ground at 5 or 6 degrees Celsius. In this case, I'm more in the 10 to 15 degrees Celsius range that I can pull water out of. And I lift that, and that provided the heat that I need in this building for all of my domestic hot water and heating needs. So that has been up and running. We're still in commissioning phase, but it has been running for the last, we'll call it a month, and so far so good. A couple of things we're working out and getting the automation worked up, but this project will reduce roughly, I think, 7,700 tons of carbon. So it was a big project and a massive reduction in carbon. And I think if I can do it to a 1929 building, yeah, I've got N-wave, but I think there's a solution for every building out there. And like we are a private equity company. We are not doing these things for the sake of doing them. We think there's a business case to be made, and we're making it on each individual project. The third project, which is part of Scotia Plaza, is 100 Yonge Street. It's a smaller building attached. It's about a 300,000 square foot building. We flipped it entirely to air source heat pump. We had end of life boilers, end of life chillers. We put a dual stage zero air source heat pump where we're running variable refrigerant units on the roof into a booster unit. We did not go into any of the spaces. This is capable of outputting 180-degree Fahrenheit water to power anything we need in the building. We got this. We've never had to run it over 160, and this one's been up and running since last November. So we had one design day of -20 last February, and we ran the building at -20. We actually turned everything on. It happened on a Friday, and as you may know, in Toronto, not everybody comes to work on Fridays these days. So we did turn all the ventilation systems and made sure we tested the system outright, and it passed. We have no boiler backup. We have no way to heat this building without these air source heat pumps. And they cut it at -30 real temperature, but Toronto rarely, if ever, sees that temperature to date. We've looked at adding, we have the capability of adding an electric boiler. We just haven't seen the need yet. So it might be something in the future we utilize, but the big thing on this project is we had a really good history of the data on it, and it's something with all the projects, understanding what the loads are on the building. In the case of the Royal York and 100 Yonge, where we switched systems, we've downsized the system substantially based on real life data. We're putting in 30% less capacity than was there before, because we have the data to show it, to calibrate the models to show that it doesn't need it. So that really helps push the business case. 100 Yonge, I didn't have to call Toronto Hydro because we didn't increase our lines. We're not increasing our peaks. Our peaks have actually reduced in this building. Overall, we have more efficient cooling equipment now, and our heating equipment doesn't pull what the old equipment pulled as peaks in the summer. Royal York, we did bring in a couple extra meg, but that was more of a locational thing. It was easier to attach things from the west side. The east side is there and was feeding the chillers, but it was a long run across the building. Overall, we don't anticipate our peaks are going to be any higher either. So I think that's where the technology side will hopefully help alleviate the things. And it needs to be done. It wasn't done because it wasn't available. It was done because it's not cheap to run new electrical feeds in and upgrade the size of your equipment. So if you can make things work, Royal York, I had the benefit. There is still a major steam easement. There's a high pressure steam line that Enwave has running through that building. I have it as backup because I don't have generators to run that building at if I have a power outage, and it's a 1929 build. Doesn't hold heat very well. So I have the ability full backup on steam. The other nice things that we were able to do on the Royal York project was the generators were end of life, and because of the Enwave and steam connection, we actually found we could provide full resiliency to the hotel by just upsizing the generators a small amount. Because we took those peak loads off, we no longer needed to run chillers ever because we have Deep Lake, and because we can flip the steam in a power outage backup situation, I don't have the heat pump heating needs. So I have the ability based on, I had two 750 megawatt generators that just provided emergency backup in the past. I have two 1 meg generators, and then right now I have a generator sitting on the street. But my new generators are sized at 1 meg. They will be natural gas, and I will have the ability to run that building with power outage and keep it open. So, and if we get in a situation where there are peaks, if Mike wants to give me a call and say, hey, I need 2 meg dropped off of the grid here, I could fire up generators and do that as well. So I think it's a good grid tenant thing to do, as well as in this situation, having a hotel that can stay open, or it's a major conference center as well. Not canceling somebody's wedding because there's a power outage, I think is a big deal. So, and when we ran the numbers with all the things we were doing, it just made sense to come back. We could have downsized the generators, but to come back and offer that full resiliency at a price point we were expecting to pay anyway with generator replacement.
Great. All right, thank you. Thank you. Okay, and we continue to have lots of Q&As in the chat. And we've had 3 case studies. There's many more around. I'm not sure who it is. Z3 Controls talks about the OAA building in Toronto and the Forestry Stewardship Center in York Region. as well as the admin annex in York Region for Net Zero Living Building Challenge. So there are a number of other case studies. We picked the 3, and we could have picked more, but great to hear. So what I'd like to suggest is we've got about 15 minutes. I'd like to open it up. If anyone, and Rachel, if you can monitor who puts their hand up and what order, and roughly what order. So if you have a question you'd like to pose to the panel, please raise your hand, and we will do the best to recognize you and put you on the unmute your mic. So do we have any questions from the floor? Maybe I'll start with, I haven't been monitoring all the chats. Have all the chats been responded to? Are there any that have not been responded to? Rachel, are you there? Oh, okay, great. David Stewart has a question I can see. David.
I think it's very exciting to see what you're doing in Toronto. I'm down here in Halifax. But the challenge is going to be, how do we double the grid in 10 years? I mean, that is going to be the the Gordian knot that we have to raise. Do you see photovoltaics everywhere in every parking lot in Ontario?
I don't mind taking a crack at that if you want.
Yep, absolutely.
So I think my perspective on what we've seen so far, and I'll obviously let others who are on the more energy production or transmission sides maybe speak more to that. But for us, what we've really noticed is that the efficiency aspect in buildings has got to be hugely considered with this, so that we're not doubling our demand in a building, just simply jamming a heat pump system onto an existing building and assume that's going to we're going to be able to supply that level of power and requirements. I can tell you for sure we have a number of heritage buildings we've had to work with, and absolutely in those cases, efficiency gets more and more costly, but and we tend to go more mechanical in those specific scenarios. But we do see a lot of push more to the efficiency side, and in my mind at least, the distribution side of it is, hey, buildings stay still. They don't have to move around at 110 kilometers an hour. If we're going to be talking about electric vehicles and buildings, it kind of benefits us to be more efficient where we can a little bit more easily in the building side of things. I'll maybe leave that there and let others speak to them on the distribution side of things.
And I'll just add, it's not only generation that's going to be a challenge, it's also transmission and distribution. There's a new concept that's gaining popularity called non-wires alternatives. And people are looking for ways of getting this additional power to sites without having to build more transmission, distribution, or generation. And so these local solutions are going to be more important. The other number I've heard is that without energy efficiency, you might have to triple the size of the grid. And with energy efficiency, maybe we can get away with just doubling it. But I agree, David, doubling the size of our grid is going to be is a huge challenge, and making sure that it's green is even more so. So thank you for the question.
Sorry, maybe just one other thing I can add on to that we have done, that we've tried to fit in with our combination of building efficiency and EVs, is we've also looked at a lot more at things like battery storage for chargers as well. So we've tried a few of those as pilot technologies to try and alleviate that huge demand for EVs charging at the same time as we're trying to heat buildings at peak load, but just something else to deal with that demand aspect.
All right, and Sarah?
Yeah, just adding, so working with a number of different distribution utilities across Ontario and Canada, a number of the distribution utilities are already putting into place what they're calling something along the lines of sustainability plans to try to figure out how their distribution system needs to grow and how, what their plans are to manage those growths. And so that is something that is very active today in the market, and something that Power Advisory is very much involved in. Just to the point that Peter made and kind of linking it to the electrification side. So utilities in their sustainability plans and trying to build out their grid more cost effectively are considering non-wire solutions, but certainly the buildings that we're talking about potentially have a lot of demand side flexibility. And utilities are today, trying to look at things like local demand response programs, really trying to offset capacity that the grid might otherwise have needed if those if that flexibility wasn't there. So this is a very active part of the discussion, but certainly not something that's being left behind.
Yeah, thank you.
Yeah, just quickly, 1 second. Toronto Hydro does have a non-wires group. So if anyone has any questions on that, reach out to me and I can put you in contact. And we also are supportive of solar, although we are the distribution, we're not generation. So we won't be we'll just help you with your connection process.
But Mike, you would have I'm sure you still have an unregulated entity that could become a generator. I mean, I know some utilities in Ontario are generators. I think Ottawa Hydro, they have a non-regulated entity that owns some of the dams and the power generation on the Ottawa River.
There is something mentioned in the plan. Nothing has been finalized at this point. Funny enough, I'm just chuckling because I was just talking to my manager, Julia, just before this meeting about this exact topic.
Oh, there you go.
But for myself and my team and the current climate action team, we're more focused on helping customers electrify their heating, domestic hot water, and EV charging. And figure
that's
out that
enough of
other
a
part
challenge.
well.
That'll keep you going. Yeah. Okay, great. Any other questions from the floor, from anybody?
Peter, you may remember that back in the late 80s, early 90s, Ontario Hydro had a program that they, for geothermal, $2,000 grant and $10,000 low interest loan. And at the end of this period, 3-year period, according to the VP of Ontario Hydro, they said with the volume of installations, they're able to reduce by a small nuclear reactor.
Yeah.
Do you remember that, Peter?
I do. Sorry, could you identify yourself? I don't see on the screen. Who's speaking?
Gina from Ground Heat.
Okay, great. Thank you. Yes, some of us are old enough to remember that. And this was, I think, under Marion Fraser when she was running the conservation programs at old Ontario Hydro. And they were very successful. And there was I'm a big believer in learning from previous experience. And fortunately, we've had some good experience. And to my view, it's one of the advantages in Ontario by having a number of LDCs. We're having different people do different things. And first of all, the same approach doesn't work everywhere, but also it's good to have people, different companies trying different initiatives and hopefully sharing successes and also sharing challenges. And that's something that consultants certainly help with. So thank you very much.
Peter, you may remember also that Consumers Gas and Ontario Hydro had purchased a 200 kilowatt fuel cell, the PC25, and this was almost emission free using natural gas. I'm surprised that that's on site, which is basically no wires needed, just the gas. We may remember that
I remember visiting it. It was at Ontario Hydro Technologies on Horning or Kipling out in Etobicoke. You're right. I mean, there hasn't been much talk about fuel cells. Ballard, of course, got big into it 10, 15 years ago with cars. And some of the car companies were talking about it, but you do not hear as much recently about it. But maybe there's someone online that knows a bit more about fuel cell development. But it has not seemed to have the profile that other generation technologies have at this point.
Peter, could I come back with just a opinion on what I've heard from a lot of the wonderful speakers here today, but
introduce yourself.
Oh, yes. My name is Quinn McGovern, and I'm with Bondi Energy. We're doing lots of retrofit work in Toronto, surrounding areas, in the US as well. And what I have heard was the example set by these sort of visionary efforts by the owners to retrofit their buildings. That each of these buildings is very much got its own character, and we've got a 1929 building that happens to be nestled up close to an N-wave pipe, and that's just terrific that N-wave's there, as well as other older buildings. For instance, the one Lee had described. One thing we're really finding is that each of these buildings has a very distinct set of strengths, issues, weaknesses, and that it really helps to go at them with a broad set of tools to be able to address it. And one of the ones that I heard Mike from Toronto Hydro also talk about is that maybe there's some opportunity for storage, on-site storage, to be one of the things that might help with individual building electrification. That maybe that could be part of the solution to be able to feed back it up and down the line. And I guess my question goes to Mike. Is there some feeling that there's that some of this network build out becomes a two-way pipe? Obviously, clearly much more difficult to manage and operate. But in a space like Toronto, maybe you can address some of that opportunity for on-site storage as one of the many answers that building owners could reach out for.
Sure. I mean, when you're saying back, are you also referring to the storage then also potentially being used to go back onto the grid as well? So be two-way, or just purely to help with a non-wires alternative solution?
I would say as a non-wires alternative solution.
All I can say, I mean, I'm relatively new to Toronto Hydro and things like that, so I can get back to you with a more detailed answer. I would just say that we are doing a bunch of pilots, some non-wire battery storage pilots to see what the impact is and such. They're still kind of underway at this time, so I haven't heard of any results yet. And there's a whole group and several groups within Toronto Hydro that are looking at all these different alternatives. And Sarah looks like she might know a little bit more.
Sure. So I'm involved as a partner in one of the Toronto Hydro projects. So just speaking to that, like a number of, so that local demand response program is making, is leveraging some of the existing customer assets that they've already installed energy storage, for example, but they also have other demand side flexibility that they could offer as well. So I don't think energy storage is sort of necessary for that demand side flexibility, but certainly gives often customers some more sort of like flexibility in terms of not interrupting their operations and things like that. I will say that in Ontario, there's a bit of a special case for the value of that energy storage because of the global adjustment cost allocation mechanism. So that kind of gives, that's a bit of a special case that, doesn't give, that's not applicable necessarily in other jurisdictions in the same way. But it's something, certainly that Ontario can kind of leverage now that that capacity has been installed.
Great. Okay. We might have time for one or two more questions. Anybody from the floor? Speak up or raise your hand or raise your yellow flag or whatever. And again, it looks just when I've scanned through the Q&As, the chat, it looks as if most of the questions there have been responded to. Thank you very much, all the panelists who've been monitoring that and responding to people. I'm sure as well, if there's something that comes up that you think of after this is over, I'm sure you could contact the panelists, and I hope they'd be happy to help you out and give you any advice or thoughts. So maybe I'll just go from maybe some final comments, just from the panel, and I'll go in the order in which they started with. So Sarah, just closing thoughts and advice to those who are attending today.
Sure. I think my big thought is that electrification of buildings is in everybody's plans now, and I don't think we would have said that a couple of years ago, that buildings would be electrifying at the rates that they are. And when I mean in the plan, I mean ISO is planning on building electrification. Distributors are planning on building electrification. Everybody's trying to figure this out, and it's a very exciting time to be working on all these projects.
Great. Mike?
I'll keep it really simple. Just reach out to my team if you have any questions for electrification and distribution.
That's very
Climate
simple.
Action Team is here to help.
Great. Lee?
Yeah, I mean, I think my parting words would just be the solutions are pretty available. Like, I don't really see a lot of buildings where I can't come up with a combination of solutions to get it there. I think the concerns, as were noted in this call a fair bit on the longer term, are around the grid and even the cost of electricity. Because as natural gas has kind of flattened a little bit, and electricity, we don't know where that's going to go. That does make it hard, not to mention the carbon tax, to forecast out as an asset manager on where we can actually afford to do stuff. So those are just some other perspectives there.
Right. And Paul?
Just building on what Lee said, I think I would add to that and just say, don't let the perfect be the enemy of the good. You know, we don't all have to be net zero or 100%, 90%. You know, let's do what you can with what you've got to start with, and then, you know, obviously as you build out your plan of how you're going to be upgrading your buildings going forward, pick out those big wins, and let's start making some savings, you know, as soon as possible.
Thank you. And finally, Joe.
Yeah, I'd say what Paul and Lee said. Like, there's a lot of big numbers and scary things out there, but like, it's all doable. The technology's there. The business case is tougher than the technology. I'm trying to make the numbers work, but like, it's doable as well. You need to really push the engineering. You need to make good decisions. You need to have the right information. But I'm slowly, I wouldn't call the Royal York an easy one, but I'm picking them off based on when their capital's due. It's not necessarily that makes a business case, not hey, this one's here and it's really easy. It's if my cooling towers and chillers need to be replaced, or my boilers need to be replaced, and I'm not going to put in a 20-year natural gas fired boiler as my solution at this point, because we have zero carbon ambitions that are way sooner than that. So you think the business case doesn't make sense for zero carbon, you start to tell executives what's the business case of writing off a boiler after 5 years. The do nothing approach sometimes it gets you more money. It gets you the money you need to do the right thing now.
Good. Thank you. Well, maybe everyone, I'll ask you to join in a virtual round of applause for our speakers. So thank you very much. and it's been great. Very insightful. We didn't have much time today, but I think we got a lot in an hour, and I'll just turn it over to a final concluding comment to Yuri.
Thank you very much for all the panelists for fabulous discussion. My key takeaway from that is that we can actually do it, and we can meet some of those targets Sarah was talking about. So that's very encouraging, and you know, particularly in the light of the recent COP meeting, you know, we hope that there'll be kind of a all system go on renewables, climate justice, and resilience. So I think we still have a work ahead of us, but you know, it's exciting that there are ways of doing it. So again, thank you very much for everybody. If anybody's got any kind of a questions still remaining, please get in touch with us, and you know, we will try to answer them as well. So again, much thanks, and to everyone, and goodbye, and hope to see you in our next webinars. Thanks.
Bye now.